pulling. So pulling in Unity, what is it? Why do we need it? What do we need to do to get it? So pulling is the act of reusing an object that has already been spawned. So when you want to create a new object in Unity, what you tend to want to do is use instantiate. But instantiate is a very expensive operation to do. So what I will show you here is my current script without pulling. All it does is it fires 1,000 bullets. Now I know it only looks like one, but we have created 1,000 bullets. And that took 25.9312 milliseconds, which is a lot for a single frame. Right, what we'll do is we will bring up the where is it? They've moved this. Is it under panels? Project. Why is there two? Oh, this is the panels that I've already got up. Oh, okay. I am looking for analysis profiler. There we go. I'm looking for this. So what we're going to do is we're going to run that, and you're going to see some spiky stuff. And we're going to hit spawn bullets, and that spike right there is us spawning 1,000 bullets. And that's not good. So the way the code works is you call spawn, you give it a count, it loops through it. All it does is instantiate the prefab at the position and rotation of the spawner. Now, give you a bit more of a thing. We can do a bit more in this. So that's 20 to 30 milliseconds to spawn 1,000 very basic, almost empty objects. There's only one script on that, and it has two variables: the speed and the lifetime of the bullet. If it was any more complicated than that, every single bit of complication adds more and more time to the instantiation routine. So we want to minimize the number of instantiations, so how we do that is called pooling. We instantiate an object, and then once it's dead, we then put that back into the pool of objects to reuse, and when we want to get a new one, we just get the old one and refresh it. So, in fact, what we'll do here is we'll just give you a random angle. Not math. Random dot Unity engine dot random dot range 0 to 360, and we will do that. We will go back into there and we will run this again just to show you exactly how stupid this is. That is 1,000 bullets. And just to show you that it is, there's 100 bullets, and you can see it's dropped down by a factor of 10. So it is linearly going up. So you can see there, that effectively took 0 milliseconds because it's not that finely grained. But that's only with 10. So what you'll also notice is that when we do spawn 1,000 of them at once, we fill up with 1,000. And then if we click it again, we fill the hierarchy up with another 1,000. And that's a lot of objects. Even though they're disabled, they won't take up much in the way of frame rate. They will start taking up more and more memory. So it's an efficiency thing. So what are we going to do about it? Well, we're going to use pooling. So the two things that you need for pooling are a pool controller, something that controls the pool, or the many pools of things. And you need to have your objects be aware of it pooling. So there are many ways to do this. Some are more complicated than others, some are more effective than others, and some require more coding for all your objects in order to take advantage of the pooling. What I'm going to do today is a very basic, a very simple, a very elegant one. There is no one-size-fits-all pooling solution. It is not something that really exists. There is always going to be some quirk that you're going to have to be aware of with each of these pooling systems. This is probably the most simple one to get your head around as a beginner, and it is the one that I use quite often because it's the most flexible, and I will do it just now. So we'll see in Bullet Mover. Bullet Mover is the script that's got to be pool aware. It's got to be aware that it has been pulled, and it has got to be aware that it has been refreshed. So it is already set up to do this, and what it does is it is going to use on enable and on disable to flag whether or not it is pullable. So what's going to happen is it's going to last a certain amount of time. That lifetime is in seconds, that's 1 second. And when it is enabled, it's going to set the private variable mLifetime equal to the lifetime that's been set in the inspector. And then every fixed update, it's going to count down. If its life is over, it deactivates itself. If it's not, it translates in the direction that it is supposed to be going. So how is this pool aware? Well, our pool is going to look for disabled objects, and it is going to say this object is pullable because it is disabled. That's all it is. Other ways of doing this would be to have a base mono behavior, for example, that is a pullable mono behavior that has a function inside it called pullable, or is pulled, or destroyed, or whatever. Something that will control the life cycle of the pool outside of Unity's built-in life cycle. But that's a bit more complicated and beyond the scope of this tutorial. We're going to use enable for this one because it's simple, because if you're a beginner or an intermediate, you will understand when things get enabled, when things get disabled, and how that can all work. What this also means is that other things can disable this, and it will put it back into the pool. So you could have another script that handles destruction and creation of the bullet. So for example, if you have like a random color script that's separate from the bullet mover, all it has to do is listen for enable. It doesn't have to then listen for disable to put itself back into the pool to know it's been put. It's simple, and it's beginner friendly. It's also quite versatile. The pitfall, of course, is that if you have an object that you want to enable and disable, say through animation, you have to be aware of this limitation that you now have. So we'll go into that more once I've done the tutorial and the downfalls of it and the pitfalls that you might fall into, because every pooling system has a pitfall of some description. There is no perfect pooling system. So, as I said, this bullet mover is set up perfectly for my pooling system. We have not written the pooling system yet, or rather, not in this project, but we will. So the first things first, how are we going to conceptually set up this pooling system? What does it need? It needs to be able to instantiate game objects. It needs to be able to keep track of disabled game objects. And it needs to know what to do when someone asks it for a prefab. So we're going to write that script. And if you have watched one of my previous tutorials on the... I should have typed in a class name there. On the singleton pattern in Unity. I'm going to call this pool manager. We're going to get rid of the namespace. So public class pool manager. We're going to make it a mono behavior. We're going to make it a pseudo singleton. Now, what the hell does that mean? Well, we're not going to follow strictly the singleton pattern that we had before. because the singleton pattern that we had before expected you to place the singleton object in your scene in order to access it. The pseudo singleton will not require you to place your own object, it will create one at runtime for you. So we're going to do public static pool manager instance. Actually, yeah, we're going to make that private actually. And what we're going to do is, because we're not going to access it through instance, we're going to create some static functions. And we're going to then pass that on to the pool manager mono behavior. So there's going to be two levels to it. There's going to be the static level up here, which all the other scripts are going to reference. It's going to be the interface into the actual pool manager itself. Nothing should access the instance of the pool manager. The pool manager is something that we're just going to detach and reattach, and we can shuffle about, because Unity's a bit weird. And we don't like using statics all that much, especially static variables. So we want to only have one static variable, and we don't want to really access it. Anyway, what we're going to do in here is private static pool manager create new. Equals there we go. So again, just a refresher, why am I using equals here rather than is equals? Well, Unity has this weird thing about nulls. And when a game object is destroyed, the components don't really get destroyed. The game object itself doesn't really get destroyed, like not in the traditional C# sense of the word. It gets shunted off to the side and ready for garbage collection. While it is getting ready for garbage collection, it will return null when you do the equality against it. However, sometimes it doesn't. So whenever you're doing something as a static like that, it is always, it's a, how can I put this? It's a guarantee. The problem I have with Unity is if you do minstance, if you do that, you're not really 100% guaranteed that that will be true. In this case, it probably will, because pool manager is going to be an object on the field. It's when you get into generic types and things like that that it starts to flake. It's when you get into subtypes and polymorphism and stuff like that, when you start getting into the deeper stuff of C#, that the equality, the overridden equality function doesn't get carried over when you're using abstract types, not abstract types, if you're using unknown types, dynamic types, object, the object type, things like that. So whenever I'm doing something slightly dangerous like this, I'm always checking for that, especially if you have, as we have in this project, we go into project settings, if we go into the editor, we're using the experimental play mode options, because god damn it, I like hitting play and for it to actually work. Although of course we are in the middle of writing bad code, so it won't actually play. But the reason we've got those experimental settings checked is because going into play mode right away is really good for tutorials. So what do we want to do here? Well, we want to create a new pool manager. we want to create a game object. And we want to call it Pool Manager. So why do we do it this way? Because what we can do, again, is in here you can give it a tight list of components. Well, we then have to do get component here, and that's just a little bit extra overhead. So we create a new game object, we add the component Pool Manager, and we just return that. So that's all we really need to do to set up the singleton. What this means is if you change scene, your pool gets destroyed. That's the key part of this. When you change scene, instance will still technically be set, but it will be null. And it'll be this weird pseudo null. So that is why I want to ensure that we're doing the equals here rather than the equals equals checker. Because it's not 100% and I want to be sure. So this is us set up our pseudo singleton. You can technically create more pool managers, they just won't do anything. So we need this. And now if there are any programmers in the chat watching this or watching this on YouTube, you'll be screaming, "The fuck are you doing?" Well, this is just a very short, naive introduction to pooling. I'm not going to go into making it more efficient. Again, there are pooling solutions out there that will be more efficient. This is just getting the concept of what you're doing in your head pool-wise. So what do we have here? We have a dictionary whose key is a game object and whose values is a list of game objects. So this list of game objects is going to be your pool. It's going to be your instantiated game objects. This one here is going to be your prefab. It is going to be the original game object that is going to be instantiated and pooled. So what do we do now? We need a function called make So one of the things you're never going to get past is actually having to create and instantiate your initial pool of objects. That's always going to be an overhead. You're always going to have to create the object at some point. It's something that will happen. So you're going to have to hit that that 21 or 29, 20, 30 millisecond for your 1,000 bullets. You're going to have to hit that at some point. But the bonus of pooling is you only have to hit it once. So we're going to create our pooled objects. So contains key. If pools doesn't contain key prefab, pools dot add new list game object count. That will just create morning ship. This will just create a dictionary entry in the pools dictionary with a list that has the number of things you want to put into it. Now, list in itself, bit more overhead than just an array, but for pooling, it's much easier to get your head around than doing an array. It's also technically more efficient using an array, but you're changing the size of this array quite a bit, especially when you start adding more things into the pool. So we're using a list for now. Or rather, this tutorial will use a list. You can change the thing you're using later on, especially when you get into optimizing finding a pullable object, but we'll get into that later. So we want to create a new object, so we instantiate our prefab and we add our instance to it and we disable the object. So as I said before, disabling and enabling the object is what's going to flag the pulled object as being able to be pulled. So we're creating our list of items and we are instantly saying this is going in the pull. And then we're going to do public game object get. So we're going to get a prefab from the pool. So if pools does not contain this prefab, we're going to make, we'll say we'll make 10 of them. So if the pools doesn't exist, we're going to create 10 of them. That is all we're going to do. And then what we're going to do is we're going to do pools prefab so we're going to get the first pulled game object if the game object is null. If we have no game object ready to be pulled, we want to make some more. Now, there are different ways of figuring out how many you want to make. Personally, it's a matter of choice. It's a matter of your opinion, and it's a matter of how efficient you want to be. Again, I'm just going to add 10 onto this list. Normally what would happen is you would decide on a nice algorithm for it. So say you would change how many you do depending on the size of the list is right now, or depending on how many you've called recently, something like that. But what we want to do now is then we're going to do that. We're going to make 10 new ones and we're going to return that. Actually, we're going to do this the different way around. There, that's a bit more better. So we get the pulled game object. If it's not null, we return it. If it is null, we make 10 more and we go and grab another one. Now, you might notice these two lines of code are rather redundant. What we could do is that. Problem there is you get into the tiny little problem of recursion. And recursion is bad. Because that could easily go into an infinite loop if you've screwed something up. Now, it's probably not going to screw up. But in the case that this does return null again, it won't. You won't end up with a Stack Overflow exception, you won't end up with an infinite loop, and you won't end up wondering what the hell is going on. So, a little bit of redundant code there is fine. You've just got to make sure that it is the same line of code. So that's us getting. We're making and we're getting. Now the problem is I've marked this as private, so what are we going to do? Public game object should make that static. Public static what we're going to do is we are going to make those private. My head's not screwed on today, that's right. So now we have get and make as instances or static functions as opposed to part of the model behavior. So what we can do in spawner here is instead of instantiate, we can do pool manager get prefab and then we can do all this stuff that instantiate would do. So and then we set it to true. Now what you could do, and what I would consider doing, is setting it active in here. However, that's not really the domain of the pool manager. Now there is a thing. If this wouldn't be thread safe, then nothing in Unity should assume to be thread safe. Good God. So what could happen is you could call get on this, you can get your pooled object, and before it does all this stuff and sets active to true, something else could call it and get the same object, and you could have a conflict. But we don't care because we don't really work with threads all that much in Unity. You would have to care about that if you're doing something like the job system, which is why you get, at that point, if you're working with the job system or if you're working with threads, you look into a proper pooling system. You don't use this naive thing. But this is fine for anyone doing some nice single-threaded basic programming, like most of us are. So this should spawn 1,000 on the first time round. It'll give us our time to spawn is stupidly high. There we go. And we've half the time. We have half the time, and we are no longer spawning. We are no longer spawning extra things in the scene. So we have dropped that spike in half, which is great. Now, what we'll do is, what will we do? I mean, that is the basics of pooling. That is pretty much just pooling on its own. So what I can do is I'll spam this and show you that. Oh, see, this is one thing that we've got to be sure about. Ah, yes, okay. This is the problem that we're having with, yeah. Yeah, so we want to, this will hopefully fix that. We'll go in, we'll spawn our bullets, come back out, we'll go back in, we'll spawn our bullets. There we go, okay. So that again is the problem that I've had with the experimental things. You have to make sure that when you disable this object, you make sure that you tell it that it's that. This equals didn't work because it was still that static was still pointing at an object that was destroyed, but but still existed. So when I tried to access it, Unity was like, no, I'm just going to throw an exception. So yeah, that on disable will also mean that when you change scene, it will unregister itself and we can create a new one. You do not want this one to start up with don't destroy unload. This is the one. This one you do not want to be yeah. So this pool manager, you do not want this to transition between scenes. You'll also notice that it doesn't create the pool manager until you actually want to pull something. So what we'll do now is we will do something. We'll change the spawner slightly. We'll make it a coroutine, and we will make it a timed thing. So it will just keep going round and round and round and round every couple of seconds. And we will give it a timer. We'll give it time between spawns. We also don't care about timing it because we're not benchmarking anymore because it's going to take a minute or whatever. So now when we click this button, it'll go and start firing in random directions. And as you can see there, it created 10 because that's how many we said to create by default, but it's only looping through those 3. Now what we can do here is we can go 0.1. So it will be spawning 10 bullets a second. And as you can see here, the pool increased to fill. So what we will do is we will bring up the profiler again. Profiler is very useful. So what we'll do is we will spawn bullets. You can see there is no change in that. You can see there was a small spike. Well, we missed it, but there was a small spike when it created all the new bullets. But it quickly returns. Yeah, so it returns quite quickly back to its baseline. It doesn't keep spawning. So that's the end of that one. We'll just press that again. As you can see, it will loop through. It'll just keep looping through all of the bullets. Quite quick. Until it stops. Make it spawn 10,000. Again, you can see it's still easily. The biggest problem right now is rendering all the bullets on the screen. You can see it's sort of peaking the frame rate as more and less bullets get enabled and disabled. But there is nothing with the actual creation of them. So we can fudge this. We can set this to. I'm just going to set this to 100,000. I will probably crash Unity right now, but we are going to so we are now there. We're going to spawn bullets. It's thinking. So there we go. There is the spike that launched 10,000 bullets. You can see there. It's stupid. It's still thinking about it. But the main problem right now is that it's not Unity that's slow in rendering this. It's not the game that's slow in rendering this, it's the editor. So there are currently 10,000 things in the hierarchy. What I can actually do, this is a bit of on the fly thing. Rather than instantiating it there, we are going to set its parent to the puller. Experience has taught me that the editor itself is not that efficient. But this is what we're testing. I don't know for certain, but this is what I'm testing. So again, we'll play. We'll let it go off. We'll spawn the bullets. It'll do its little thinky thing. Yeah. So as you can see there, it's fine now because all of the objects are hidden under that thing. So now that I've clicked on it, it's thinking about it because in this editor window, it's now showing you all the gizmos for that bullet. So if I click on this, it's now trying to show all the gizmos for all those bullets, even though it's hidden. And once I unselect it, it goes back to normal. Experience. And again, if I click on that, yeah. Because those were all, yeah. You've got, one of the things you've got to learn with Unity is that the editor is not perfect. It's good, but one of the things that I learned while doing editor scripts, my old job, I did a lot of editor scripts because we effectively had a 3-man team. I was the only programmer. Yes, the fact that the editor is rendering the hierarchy, and not only the hierarchy is not that much of a thing on it, it's the gizmos. So the bounding boxes and things like that. All that kind of stuff. All right, okay. I was like, why? All right, I'm assuming that your enter key. Ah, okay. Bit of a weird keyboard, but fair enough. Yeah, I fat finger stuff all the time. If you notice that when I'm doing code, if I hit the semicolon, I often hit L instead. Fat fingering thing is definitely a thing that happens all the time. So what I remember to do is to turn that down a bit, because that's excessive. That takes away the entire point of pulling. If you just go, nah, I should create 10,000 of them, or 100,000 of them, and slow the thing down. But that's the basics of that. The thing is, the way that this works, because we have a dictionary of game objects, each prefab that you send in will 1 million. No, I'm not doing 1 million. That will take about a minute to instantiate them all, because that took a good 5-10 seconds. If we do 10 times that much, it will take 50 to 60 seconds. It will be a lot more, 10 times more. So yeah, the reason that we do a dictionary and we have the key as the game object, the key will always be the prefab. Incidentally, it doesn't actually have to be a prefab. what I can do is I can create a game object here, and instead of doing that, it can be a game object that's in the scene already. You can see there the game object, it's just an empty game object. You tend not to want to do that. There are some instances where you would want to do that. I've done it before with UI. One of the things that this can be good for is lists. So if you have a UI list of objects, you don't want to be displaying that entire list. If you've ever done any mobile programming, the scrollable lists that you get on phones, if you swipe up and swipe up and swipe up, the infinite scrolling swipe ups, they are not showing all those objects at the same time. Once it goes off the screen, that object gets pulled and stuck on the bottom and turned into a different object, and you just keep scrolling up. So pulling is good for that. And in that instance, with Unity, what I would do is you would have your base object, because you want to also be able to see how it looks in the editor. You would have this button here in your list to see how it fits in the list, how it does all that, and then you just disable it, set that as the prefab of the spawner, and when you come to do your list code, you will just instantiate that non-prefab object. React Native, yeah, exactly. It's all abstracted away in infinite scrolling. So I used to do Xamarin. Xamarin has as much abstraction as you want, and not enough abstraction at the same time. iOS is, it basically goes, right, here's code link into iOS's stuff, here's code link into thank you, here's code link into Android's one, but what you have to do, I believe what you had to do for the iOS one was give it an object that you wanted to infinitely scroll. So essentially you're giving it the prefab that you want to reinstantiate over and over and over and over and over again. And it was a bit of a nightmare to get your head around sometimes. But that's basically how I know how the infinite scroll works, is because it gave you just enough abstraction to not care, but not enough abstraction to not have to do something for it. So it's all a bit off. But that is essentially the basics of pooling. It's a very simple, very naive, very hopefully easy to understand example of getting pooling to work. You need a make, you need a get, and you need a way to put something back in the pool. Those are the three things that are required for pooling. How you implement that, how you decide what has authority over what. So the way that I would normally do pooling, and which I did here, was that the object itself, the bullet mover in this case, cares about when it gets unpulled, when it gets reinstantiated essentially in the onEnable function is where I've put that. And it determines when it gets put back in the pool by flagging itself as disabled. Now, if you were going for something more complicated, like if you were going for a base class, or if you were going for a pooling component, the pooling component would be the thing that determines when it goes back into the pool, and each of the scripts would probably ask the pooling object, can I go back in the pool please? I'm done. And it will decide when to put it back in the pool. There's lots of different ways of doing things. There are quite a few pooling ones on the asset store. Some of them are open source. If you're curious as to how other people do it, you can always look at their open source. This code will be going up on my GitHub repo. When we put this on YouTube, the link will be in the description. And it will be the same repo as all of the other tutorials that I have done. But that was pooling. I haven't decided what I'm going to do next week though, so stay tuned for that. This is the end of the series that I was planning on doing. It started with the Singleton stuff and ended here, sort of pseudo using the Singleton stuff, and all the other ones previously kind of merged in the Singleton idea in there as well. So I'm going to have to think of something else. I'm probably going to do factory patterns at some point, service layers, things like that. Service layers is a weird one because Unity really doesn't. Game development in general doesn't really suit the service layer model, but it is really useful for databases, web, sorry, and web dev. So that's the background that I come from. So I really like the service model, service repository model. So I might do a way of doing that. It's quite a good way of doing database stuff. And if you do have a database in your game, so if you have a SQLite database, which I have done before, then doing a service model, doing an inversion of control actually is quite an interesting one. I might do an IOC tutorial for Unity. Yeah, that's a good idea. I might end up doing an inversion of control and service layer series next. I'll have to plan up that. But that is the end of the tutorial. As I said, link will be in the description when it goes up on YouTube. If you are on YouTube, come check out my Twitch. We'll be doing this every Thursday morning at 11 AM GMT. Check out the Twitter and check out my itch.io page. I have just released a new game, which made last week during AGDQ, which is one of the other reasons why my sleep schedule was knackered and I didn't stream last week, was because I was watching Speedrun Marathon and making game. Linked together to have no sleep. Well, not no sleep, just not decent sleep. It's like, oh, I'm watching this speedrun. Oh, it's 1:30 in the morning? Oh, okay. Well, I guess I'm not getting up till 10 then. So, yeah, wasn't in the mood for streaming last Thursday. But now that the marathon's over and the game jam is over, I should be back to normal.